You ever wonder how your email just knows what's junk? Or, how your photo app can pick your face out of a crowd? Well, it all boils down to one big question. How do we actually teach a computer to sort, well, everything? Today, we're going to dive into exactly that. We'll explore 3 really clever ways machines learn to classify the world around us.
I mean, think about it. Every single day, we're relying on machines to make these calls for us. Is this email important or is it spam? Is that thing in the picture an apple or an orange? This fundamental task, this sorting of items into groups we've already defined, well, in machine learning, that's called classification.
So, what does that really mean in plain English? It's a type of supervised learning, and all supervised means is that we start by giving the computer a ton of examples that are already labeled correctly. We show it thousands of emails we've marked as spam and thousands we've marked not spam. From all that training data, its job is to figure out the underlying rules so it can predict the right category or class for any new thing it sees. All right, our first method is probably the most intuitive one you can imagine. Seriously, think of it like a game of 20 questions. You try to figure out what something is just by asking a series of simple yes or no questions. That is exactly how a decision tree works. So let's look at a puzzle. Here's a bunch of data. We've got the weather outlook, the temperature, humidity, and wind for 14 different days. And that last column tells us whether or not we ended up playing tennis. Now, if you're a computer, where do you even begin? What's the one single question you could ask that would give you the most bang for your buck? And here's the solution the machine comes up with. It's this awesome flowchart. See, it figured out that the best first question to ask is about the outlook. Because if the outlook is overcast, boom, you always play tennis. Done. But if it's sunny, well, then the next best question is about the humidity. And if it's rain, then you need to ask about the wind. It's just a clear, logical path to get to an answer. Okay, so how does it find the best question? There's a fancy math concept called information gain, but we can boil it down to 3 simple steps. First, the machine looks at all the possible questions it could ask, like, is the outlook sunny, or is the wind strong? And it calculates which one of those questions will do the absolute best job of splitting the data into cleaner, purer groups. Second, it divides the data up based on the answer. And finally, it just does it all over again. It repeats the process on each new smaller group until everyone in the final bucket belongs to the same class.
Okay, let's move on to our next strategy. This one operates on a principle we all kind of get. You are who you hang out with. It's called K-Nearest-Neighbors, or KNN, and it basically classifies something new based on the company it keeps. Now, what's so interesting about KNN is that it's known as a lazy learner, and it's called that for a good reason. Unlike that decision tree, which did all this hard work up front to build a model, KNN is, well, it's lazy. During its so-called training phase, it does next to nothing. It just memorizes all the labeled data we give it. It waits until the very last second when we ask it to classify something new to actually do any real work.
Let's make this really concrete. Imagine we've got a chart with a bunch of fruits plotted out. We put them on the graph based on 2 things, their weight and their color. So you can see the apples are kind of hanging out in one area and the oranges are in another. Now, a brand new mystery fruit pops up on our chart. How in the world do we figure out what it is? Well, the very first thing we have to do is choose a number, K. And K is just how many neighbors we're going to ask for their opinion. Choosing K is super important. If K is too small, like just 1, our decision could get totally thrown off by one weird neighbor. But if K is too big, we might be looking so far away that we miss the local patterns. It's a balancing act. For our fruit example here, we're going to set K to a nice, simple 3. So what happens next is pretty cool. The algorithm calculates the distance from our mystery fruit to every single other fruit on the chart. Then it finds the K closest ones, in our case, the 3 nearest neighbors. And look at that, 2 of them are apples and 1 is an orange. So the algorithm just takes a simple majority vote. Since apples win 2-1, our mystery fruit gets classified as an apple. Simple as that. And don't let that simplicity fool you. KNN is incredibly powerful. It's the engine behind recommendation systems. Customers who bought this also bought. It's used in medicine to help with diagnoses by comparing a patient's symptoms to similar past cases. It's used to detect financial fraud and even to recognize handwritten numbers. All right, our third and final method takes a much more geometric approach. It's less about asking questions or polling the neighbors and way more about finding the most decisive, clear-cut dividing line you can possibly draw between 2 groups. This is the support vector machine, or SVM. The whole idea behind an SVM really shines when your data is what's called linearly separable. It's a fancy term, but all it means is you can draw one single straight line that cleanly separates all the blue dots from all the red dots, just like you see in that graph on the left.
But as you can probably imagine, you could draw a whole bunch of different lines that do the job. The goal of an SVM is to find the single best one. This dividing line is called a hyperplane, which is just a term for a line that can separate things in many dimensions, not just two. And the goal is to find the optimal hyperplane. The way it does this is brilliant. The best line is the one that creates the widest possible street between the two groups. This street is called the margin. And the data points sitting right on the edge of that street, those are the support vectors. They're the crucial points that actually support or define the boundary.
Now, this is all great for nice, clean data. But what about the real world? What happens when your data is all mixed up and there's just no way to draw a single straight line to divide the two groups? This is where SVMs get really, really clever with something called the kernel trick. Look at the picture on the left. In that flat 2D world, the data is just a jumbled mess. You can't separate it with a line. But what if we could somehow project that data up into a higher third dimension? All of a sudden, from this new vantage point, we can easily slice a flat plane right between the two groups. The kernel trick is basically a super efficient mathematical shortcut that gives us all the benefits of that higher dimension without having to do all the crazy heavy computing. It's an amazing way to find a clean separation in a much more complex space. So there you have it. 3 totally different ways a machine can learn to classify things: by asking questions, by polling the neighbors, and by finding the widest possible divide. And the big takeaway here is that there's no single best method. It's all about having a toolbox and knowing which tool is right for the job at hand. Let's just do a quick recap. The decision tree, with its simple if-then flowchart, is amazing when you need to be able to explain why a decision was made. K-Nearest-Neighbours, with its majority vote idea, is super straightforward and works great for simpler problems where things that are alike are also close together. And the support vector machine, focused on finding that widest dividing line, often crushes it with really complex, high-dimensional data where the separation isn't obvious at all. From figuring out spam to helping diagnose diseases, classification is truly a cornerstone of our modern world. These algorithms are powerful tools that learn from the patterns we show them. So I guess the final question is really for you. Now that you have a peek behind the curtain at how machines learn to sort our world, what's the first thing you would teach them to classify?